Hello, Algebra 2 boys and girls, and we are going to talk about some operations with functions, getting ready for our test. So just a reminder, functions are instructions telling you what you are going to do with input values. Remember, input goes into the function and output will come out. So we've got the f function, the g function, and the h function are all given. So number 1 over here is f plus g of x. Remember, that means f of x plus g of x. All you're doing here is adding the functions together. So 2x plus 6, because that's f of x, plus g of x, which is x squared plus 5x plus 6. After that, all you've got to do are find like terms. There's an x, there's an x, there's a constant, and there's x squared. Combine them, x squared plus 7x plus 12. That's it. Number 2 is just a difference, g of x minus f of x. This one might be helpful to use parentheses. So x squared plus 5x plus 6 minus f of x, 2x plus 6. Remember, whenever we're subtracting, it might be necessary to distribute a -1. So we end up with x squared plus 5x plus 6 minus 2x minus 6. Find those like terms, x squared, x's, and the constants. This time the constants cancel, and we end up with x squared plus 3x. Now, I will squeeze h times f of x. There is no symbol in between h and f, so it means straight multiplication of h of x times f of x. So that is h of x, which is x squared minus 4, times f of x, which is 2x plus 6. You just need to use the distributive property twice. First on the x squared, that will be 2x cubed plus 6x squared, and then distribute that -4, which will give us -8x minus 24, and that is the product simplified. So we're going to continue here. I'm not going to do every single one of them, but notice the difference in number 4 and number 5. This is g of x over h of x. This is f of x over g of x. The order is very important. So let's try this one right here. So if we have f of x, which is 2x plus 6, over g of x, which is x squared plus 5x plus 6, this is the quotient. Now, one thing we could do here is look to see if it might simplify. And what I see is that 2x plus 6, we could factor out a 2. If we factor out a 2, we are left with 2x divided by 2 is x, plus 6 divided by 2 is 3. On the bottom, it's also factorable. Factors of 6 that add up to the 5 are going to be x plus 2 and x plus 3. So what happens here, if we have 2 times x plus 3, that's straight from the top, over x plus 2 times x plus 3, we magically are going to have something cancel in the x plus 3's, leaving us with a simplified result of 2 over x plus 2. There you go. That's our quotient. Now, number 6 is h of f of 3. Remember to work from the inside out. F of 3. What is f of 3? The f function says double and add 6. So we will find f of 3 when we double the 3 and add 6. That's 6 plus 6. That's 12. So f of 3 is 12. Making myself a little room. So now we're going to substitute that in. F of 3 is 12. So what is h of 12? What does the h function tell us to do? It says square the input and take away 4. So h of 12 is 12 squared minus 4. That's 144 minus 4. That is 140. Remember, whatever is inside the parentheses is simply the input. Now, if we move on down to 7 and 8, same thing. This is g of f of x. This is f of h of x. I think it's probably beneficial. Let's do f of h of x. So what is h of x? H of x is x squared minus 4. It is a given. We're going to take it and we are going to substitute it in. F of h of x, which is x squared minus 4. What does the f function tell us to do? Double and add 6. So let's do that. 2 times x squared minus 4 plus 6. We're doubling it and we're adding 6. We will use the distributive property and get 2x squared minus 8 plus 6. Combine the like terms, 2x squared minus 2, and we're done. This is factorable, but our objective here is to evaluate. So don't factor, just leave it. So that is function operations. Next we had finding inverses. If you look back in your notes that we took in class, we found there were 4 steps in finding the inverse. The first step is to replace f of x with y. The next step is to transpose the x and the y, just flip the x and the y. X equals y minus 5 over 2. And then our last step is to solve for y. So it looks to me like I should cross multiply, which I'm going to do here. So this is x over 1 equals y minus 5 over 2. Cross multiply. 2x equals 1 times y minus 5 plus 5 plus 5. 2x plus 5 equals y. So if our function is x minus 5 over 2, our function inverse, which remember the notation for the inverse function is f to the negative 1 power of x. So I'm just now going to replace that y with function notation. F inverse of x equals 2x plus 5. Same thing here. I'll do it quickly. Y equals x squared plus 12. X equals y squared plus 12. Following the steps, minus 12, minus 12, x minus 12, x minus 12 equals y squared. How do I undo y squared? I take the square root. So I end up with y equals the square root of x minus 12. And once again, utilize the function notation. F inverse of x equals the square root of x minus 12. You're going to do the same thing with number 11 that we did for 9 and 10. Number 12, different set of instructions. Number 12 says, determine if h of x equals 6x minus 2 and g of x equals 1/6x plus 3 are inverses. To do that, we have to do 2 algebraic functions here. The first one, h of g of x must equal x, as well as g of h of x must equal x. So ask it with a question mark. Is this a true statement? So let's do it. We're going to put the g function into the h function. There's the g function. H of 1/6x plus 3 going into the h function. What does the h function tell us to do? Multiply by 6 and take away 2. Let's do it. 6 times 1/6x plus 3 minus 2. We're going to use the distributive property because we are evaluating. So 6 times 1/6 is 1x. 6 times 3 is 18 minus 2. We get x plus 16. Does that equal x? No, not an inverse. And very honestly, if you get a no on the first one, no need to even do the next one. It's not going to work. It has to work for both of them to prove that they are inverses. Let's do the one on the bottom very quickly. F of g of x. Do we get x? Question mark. Let's see. F of 1/4 x squared minus 5. So notice that I just put the g function in there. We're going to take this whole expression. Remember, everything inside the parentheses is an input. We're putting it in for that x. Let's go. That's the square root of 4 times 1/4 x squared minus 5 plus 20. So when we distribute right here, we end up with the square root of x squared minus 20 plus 20. 20's cancel. The square root of x squared is x. All right, we've got a winner on f of g of x. Now try g of f of x. We better get x. We're asking it as a question. G of f of x. F of x is the square root of 4x plus 20. It's going into the g function. So that is going to be 1/4 of the square root of 4x plus 20, and remember we're squaring it, minus 5. Follow order of operations. The square will undo the square root because they are truly inverses. Then we get 1/4 of 4x plus 20 minus 5. Distribute the 1/4. 1/4 of 4x is x. 1/4 of 20 is 5 minus 5. 5's cancel, and you get x. Check. These are definitely inverses. Definitely inverses. That's the test. Continuing on, simplifying each expression. We did practice a couple of these in class today. Remember, be sure to check the index of the radical. This is a cube root, and we are going to start by making a factor ladder. So we're dealing with 216. 216 divided by 2 is 108. Divided by 2 is 54. Divided by 2 is 27. Divided by 3 is 9. Divided by 3 is 3. So look at what we've got. 1, 2, 3 powers of 2. 1, 2, 3 powers of 3. Make the substitution here. 2 to the third, 3 to the third, x to the 12th. Remember, the key to doing these is to simply compare the index with the exponents. The base is going to stay the same. 3 goes into 3 one whole time, none left over. 3 goes into 3 one whole time, none left under. 3 goes into 12 4 whole times, none left under. The cube root of 216 x to the 12th is 2 times 3 times x to the 4th. That is 6x to the 4th. Next, 15 and 16, both of them have 32 under those radicals. We've talked about in class how important it is to know that 32 is 2 to the 5th. That will save you time from having to make that factor ladder every time. So very quickly here, let's simplify the 4th root of x to the 5th over 32. First of all, remember that means the same thing as the 4th root of x to the 5th over the 4th root of 32. Save you some time. Go ahead and divide that up. So 4 goes into 5 one whole time with 1 left under. Over 32, of course, is 2 to the 5th. So think about it as 2 to the 5th power. There we go. 4 goes into 5 one whole time with 1 left under. Now, we're going to get into simplifying and rationalizing radicals after our long weekend, but this one is a little bit tricky, and this one can be simplified more, but I'm going to save that for another video. Let's look at 16. It's the 5th root of 32, x to the 7th, y to the 1st. So this is the 5th root of 2 to the 5th, x to the 7th, y to the 1st. 5 goes into 5, 1 whole time, none left under. 5 goes into 7, 1 whole time, with 2 powers left under. 5 won't go into 1, that's why the y is left under. So what are we left with? 2x, 5th root, x squared y. Remember, you must write the index. Otherwise, it's not a fifth root, it's a square root. Please remember to write it. 17, 18, 19, we're using fractional exponents. A reminder that the denominator of the fractional exponent is the same as the index of the radical. So there we go. We've got a 3/2 power. That means an index of 2. And I like to put that 3 now on the outside of the radical. And the square root of 81 is 9, and 9 cubed is 81 times 9, which is 729. There you go. Let's skip over to number 19. This is the cube root of -8 raised to the 4th power. Can we take a cube root of a -8? Yes, we can. We get -2. So that is -2. -2 to the 4th is -2 times -2 times -2 times -2. That is 16. That is now simplified. 20, 21, 22. We are given an expression as in an exponent form and simplify if possible. So rewrite it here. We end up with 7 to the 2/2. 2/2 is equal to 1, so it's just 7. Next, the 4th root of 12 cubed. So 12, of course, is 2 squared times 3 to the 1st. 4 times 3. Now, if we cube everything, you can write the 3 on the outside, or you can write it on the inside. They mean the same thing. So what does this turn into? This actually turns into the 4th root of 2 to the power 6th. So we end up with 2 to the 6th times 3 to the 3rd. Now can we simplify the radical? Actually, yes. 4 goes into 6 one whole time with 2 powers left under, but last the 3 stays under. So we end up with 2 4th root 4 times 27, which is 108. That one's a little bit tricky. Let's keep moving. 23, 24, 25. Using the properties of exponents. Are the bases the same? If they are, and we are multiplying, then add the exponents. 6 to the 5/2 plus 1/2 power. 5/2 plus 1/2 is 6/2, which is 3. 6 to the 3rd, and that, of course, is 261. So the next one, we are dividing, and once again, are the bases the same? Yes, they are. So subtract those exponents. But the power of the denominator is greater, so whatever is going to be remaining is not going on the top, but it's going on the bottom. So if you want to think about it like this, you can 1/3 to the 7/2 times 3 to the -1/2. If we flip that 3 to the 1/2 to the bottom, it becomes negative. So we end up with 1/3 to the 6/2. 3 to the 6/2. 6/2 is 3. It's 1/3 to the 3rd. That is 1/27. Next, number 25, if we follow order of operations, this one's super simple, because if we do what's on the inside first, that is 100 to the 1/2. That's 10, because the 1/2 power is the same as the square root. So we end up with 10 cubed, and 10 cubed is 1,000. So very quickly, 26, and the typeset's a little bit off, but 26 is up here. Think power to power, so everything is getting raised to that 3/4 power. So you end up with x to the 8 to the 3/4. 3/4 of 8 is 6, and y to the 4th to the 3/4, that is y to the 3rd, and that's it. Nothing else to do there. Number 27, power to power, so both of those factors are getting raised to that 2/3 power. So we've already discussed how the denominator of the fractional exponent is the index of the radical. So this is 8 times 27. Don't waste time multiplying 8 by 27. Realize that 8 is a perfect cube and 27 is a perfect cube. Yes, 8 is 2 to the third and 3 to the third is 27. So what's the cube root of 8? 2. What's the cube root of 27? 3. And then, of course, since we have that 2 on the top, all of it is getting squared. So we end up with 6 squared, which is 36. Number 28 is negative 8x to the 18th raised to the 2/3 times y to the 6/3. So we can follow order of operations here. Let's go ahead and simplify this. It's the simpler one. 6 divided by 3, or 3 into 6, is just y squared. Y squared's popping out. Negative 8 to the 2/3, we just did 8 to the 2/3 right over here. 8 to the 2/3 is the cube root of 8, which is 2. 2 squared is 4. So we end up with 4. And then x to the 18th to the 2/3, power to power, 2/3 of 18 is 12. So 4, x to the 12th, y to the 2nd.